All right, we're going to do problems 1 through 5 on day 4. The first one deals with the derivative of arctangent, and that's something that we didn't cover in class. You had some videos, and the video that you watched showed you that if you took the derivative of inverse tangent, and arctangent is the same thing as inverse tangent, so whenever you see this, it means the same as that, vice versa. What it said was the derivative of that was 1 over 1 plus x squared. Okay, so if it's just a plain x, that's how it's going to be. If it's anything other than a plain x, so in this case 4x, it's just a chain rule. So in other words, we're going to take this 4x and we're going to put it in there. And then we're going to take the derivative of 4x, which is 4, and multiply it out there. So in other words, the derivative of arctan of 4x is equal to 1 over 1 plus 4x squared times 4. And so I end up with 4 over 1 plus 16x squared. So that's our general of arctan 4x. Then the next thing they say is, well, what happens when x is 1/4? So we're going to have 4 over 1 plus 16 times 1/4 squared. 1/4 squared, 1/4 times 1/4 is 1/16, times 16 would give us 1 here. So 4 divided by 2 gives us 2. So you have to remember this arctan. All right, in case it pops up, not sure, doesn't come up often, that's why we didn't cover it in class, but you never know what they might throw at you. All right. Number 2 gives us a graph here, and it tells us that this is a graph of this function, but they don't tell us what a or b is, and we're supposed to figure that out from what we see. So there's two things. We see a horizontal asymptote and we see a vertical asymptote. So I'll start with the horizontal. Anytime you see a horizontal asymptote, what that's connected to is what's happening as x gets bigger and bigger and bigger, at the limit as x goes to infinity. So if we were to let x get super, super big, the 12 wouldn't matter, the b wouldn't matter. All that would matter would be right here. And so as x gets bigger and bigger, the graph is going to go to a over 1 or just a. And we can see from the graph that as x gets bigger and bigger, it's going to 3. So that means that a has to equal 3. That's the horizontal asymptote. All right. So a has to equal 3, so I can get rid of this, and I can get rid of that, and I can get rid of that. So that leaves me with just those two right there. All right. So then the second one's, to figure out between these two then, I have to look at the vertical asymptote. So right now my vertical asymptote is at 2. How would that happen? That would happen if I had an x minus 2 on the bottom. Because of the nature of this here, there's no middle term, it's just x squared and b. So the only way that that would happen is if there was an x plus 2 that made this x squared minus 4. And so therefore b would have to equal negative 4. And so D is our choice on that one. All right. So you have to understand the nature of those asymptotes and how they work together. Next one we have is this sine negative 1. So this is inverse sine or arc sine. So again, this anytime we see sine negative 1, that's the inverse sine, which could also be written as arc sine. And what we were told in that video is that the derivative of arc sine is 1 over the square root of 1 minus x squared. And so just like with the first one, we have a chain rule that happens. If we have something other than just plain x in here, we can put that in, and then we have the derivative of it out here. So the derivative of inverse sine of 5x is going to be 1 over the square root of 1 minus, and instead of x squared, it'll be 5x squared, and then times the derivative of 5x, which is 5. And if you do 5x times 5x, you get 25x squared. And so C looks tempting, except we don't want it negative. D looks tempting, except they forgot the 5. The only one that has it all is E. So these aren't too bad. You just got to know the formula, and we didn't want you just to memorize it 3 months ago and have to rememorize it. That's why we waited until now to tell you about it. All right, 77 says that h of x is the antiderivative of this. So anytime, again, we see this language, h is the antiderivative of this, that means this, going this way, is the derivative of h. So in other words, this right here is equal to h prime. Okay? So it's kind of something that you can, tell yourself if you see that language on the test. If I read it this way and it says antiderivative, that means this is the derivative of that. Okay? We're told that h of 5 is equal to pi, and we want to know what h2 is. So we're given an initial value, we want a future value. So if we want h of 2, that's going to be the value we know, which was pi, plus the change from that time, which was 5, to the time that we want, which is 2. And it would be the rate of change, and the rate of change is h prime, so it's this function here. And again, really there isn't a whole lot of other ideas available to us here. That's pretty much what we have to do, right? So this is a calculator problem. So we take our calculator now, and I go to y equal, and I've got that plugged in for y equal. So I'm going to go to my thing here and go pi plus math 9 from 5 to 2 of alpha trace y1 dx, enter, and I get negative 5.87, and that's B. So not too bad once we understand what that's representing, right? Then our last one here gives us a graph of f, and it says if that's the function f from negative 2 to 2, which of the following could be the antiderivative of f? So again, if this is the antiderivative of f, that means f is the derivative of this. So really you can think of this as the derivative graph, and which of these would be the original, right? So if this is my derivative graph, it is positive from about negative 1.5 to 1.5. So since the derivative is positive here to here, I need a function that's increasing from here to here. So I look at a, and a is not increasing the whole time from there to there. I can get rid of that. I look at b, b is not increasing the whole time from there to there. I look at c, and c also is not increasing the whole time. But if I look at D, I can see that D is increasing from negative 1.5 to 1.5, decreasing on the other spots where it's negative. D is my choice.